Good day, everyone. This webcast is about ancient Sri Lankan reservoir construction. These reservoirs are called tanks, WEWA in Sinhalese. And this is a photograph of Kattakaduwa. This is a huge reservoir. And this is not the only one. There are a whole bunch of them. There's Parakrama Samudra, the biggest one. And then there's Padavia, Kaudulla, Minneri. All these reservoirs are located in Sri Lanka. These are huge reservoirs. And you don't see these kind of reservoirs anywhere in the world. Not in India, not in China, not in Greece or Rome or Mesoamerica. You haven't seen any photographs of large, humongous reservoirs like this that appear in Sri Lanka. Why? Because they don't exist. And so I would quote here from Sir Emerson Tennant, and he said, "Accepting the exaggerated dimensions of the Lake Moeris in Egypt and the mysterious basin of Al Aram, no similar construction formed by any race, whether ancient or modern, exceed in colossal magnitude of the stupendous tanks of Ceylon. The reservoir of Korud of Ispan, the artificial lake of Ajmer, or the tank of Hyder in Mysore can no more be compared in extent or grandeur with Kattakaduwa or Padavia. The conduits of Hasiki or Kanat, or the Persian of the subterranean watercourses Peru can vie with the Lara Canal, which probably connected the lake of Minneri with Sea of Parakrama with the Ambam River." Emerson Tennant. So these are humongous reservoirs. These are not some reservoir that is appear in books. They do exist. And question is, why these huge reservoirs were seen in Sri Lanka, not in India, not in China, not in Greece, not in Mesoamerica, but only in Sri Lanka. And these people were not stupid. The Chinese did all kinds of great stuff, mathematics, chemistry, all kinds of engineering, gunpowder, silk, large navies. Same thing with the Indians, the arithmetic, algebra, all kinds of steel construction. Greek, do I have to tell? No. So why you see this construction, large reservoir construction only in Sri Lanka? Well, what's the reason? Reason is a concept. The concept was born in ancient Sri Lanka. There was a concept. What was the concept? The concept was that water that falls during rainy season should be captured and stored to be used for the dry season. So this concept seems to be simple, but this is the concept that they ran with it. Again, you see this concept being used to advance the irrigation engineering of Sri Lanka. So, how did this concept came about, and why not in other countries? Why people in other countries didn't get this concept? That I don't know. That could be by chance. That could be one intelligent person just saw something and he decided, he worked on it. So how did this concept started? And I believe that, not I believe it, in Mahavamsa it says that the earliest accounts, that what they did was they had these existing natural ponds, which they call Pokkurani in Mahavamsa. Today in Sinhalese it's called Pokunu. So they saw that these natural ponds can be deepened So you remove soil and you deepen the natural pond, and then you could get more water stored. So that's the first stage. So our concept is capture the water that falls during rainy season. So that was the initial beginning. Capture it. Deepen the holes. Create holes here and there. And then they found out the water is overflowing during the rainy season. You have this water that is overflowing. Then they thought, in the second stage, why not build a dam like this? Now, overflowing water would be captured. Again, this is part of the concept. That is to capture the rainy water that falls during rain season. So now you have a bund. Now you have a problem. Problem is how to take water out of this. So now they have to build a sluice. Now they have to build a sluice. They have to build a sluice. Later on in part 1, we will discuss deeply about the sluice gates. But then they got another problem. This sluice get blasted off when they increase the size of these dams. When you increase the size of these dams, your water level rise and the sluice get blasted off. So they came up with a solution. That's called BISOKOTUWA. They understood water level here, you get less water pressure, or in this case, velocity. And the higher the water level, you get higher velocity. So they came up with the idea called BISOKOTUWA. I have a whole part 2 in this webcast I have devoted to BISOKOTUWA. And then they came up with the idea of spill. Spill is basically when the water goes over the bund, above the soil, above this soil here, the bund would get destroyed. At the beginning, what they did was they built a weaker bund in some locations. They intentionally let the water flow when there's a flood. And then once the water is gone, then they have to rebuild the bund. That was a lot of work. So somebody came up with the idea of spill. So this is made of rock. And this is kind of lower than the bund. So when the water level comes here, water would go out from here. I'm going to talk about spill more in detail in part 1 of this series. This is the introduction. And then we have the elements of a reservoir. First you have the MUKALANA, this is the forest, the catchment basin. And then they had the IHALA, which is a small reservoir built for storage, for sedimentation, and for animal use. And when you see a picture, you would understand better. And then the PERAHANA, which is the filter. And then you have the BAMMA, the bund, sluice to take the water out, spill to PITAWANA or GALWANA to spill the reservoir when there is heavy rains. And there's interest in KATTAKADUWA. This is a area that they had kind of plants that they planted to remove chemicals out of water. And GOMMANA, this is to reduce wind. And then we come into the Cascade System. So this is a something that I drew. I don't know how that good is. So here is the MUKALANA, the catchment basin, and then the water, from the catchment basin, water would come to the IHALA, or it's also called the KALUWA. It's like a storage tank. When you take a glass of water and keep it still, the sediments would form at the bottom of the glass. The same concept. So the water is stored here for some time, and also it is a good way to keep the animals away. So the animals would come and drink from this KALUWA or the storage tank or the IHALA. and they don't bother the villagers here. They don't come to the main reservoir. So it serves number of purposes. And then the PERAHANA, I will be talking more in detail in part 1. PERAHANA is basically they planted various trees that would absorb any sediment. And then you have the GOMMANA, you have the trees for the wind breaking, and then you have the main reservoir here, and the sluice to take the water out to the canal, to the paddy field, and then BISOKOTUWA to reduce the pressure, which we have a whole section on part 2. And then here the spill, if the water during the heavy rains, it could spill over here. And then you could have your village here, and they got another GOMMANA here, and the paddy fields, buffalo bathing, Kurulu, they devoted a certain area for birds, so they don't come to this area. I think probably they had some kind of a mechanic, some noise, and so-called pambeas, like human-like figures, and birds just eat from here and leave. So, and the Kattakaduwa here, it's between the Bund and the paddy fields. There are all kinds of plants here. What happens is the stored water seeps down, and this has high metal and salt, and that was not really good for the paddy field. So they planted types of plants that they knew through experience would absorb these chemicals. And they didn't have the type of labs that we have today, but trial and error, they figured some plants would absorb these chemicals and would not damage the paddy field. So this is a better picture by someone named Dhananjaya Vimukti Karunaratna. I should give credit, I obtained from the internet. It's not my picture, it's by Dhananjaya Vimukti Karunaratna. And you could see, so this is the paddy field, and this is the tank, and this is the catchment, and this GOMMANA here. As I said, these configurations could change from tank to tank. And then there's some houses, the village, and this is the, okay, now this is not really good design. I think the artist didn't draw properly. This bund should go like this. Otherwise, these houses would go underwater. So the bund should go like this. So this is the village, and this is a temple here. This is the spill when the water level goes up. Go to another picture, and this picture by Nalaka Gikiyanage DKA Pushpakumara. And I should give credit to them. This is a much more realistic picture. And you have the paddy fields here, and here is the Kattakaduwa. Here is the Kattakaduwa. They plant a whole bunch of trees to absorb chemicals coming from the seeping water. And here is the reservoir, and this is the MUKALANA, and this is the KALWEWA or the IHALA for storage and to get the sediments down to the bottom. And here you have the village, and here you have shrubs, GOMMANA here, and it's another GOMMANA here. So these configurations would change from place to place, but these are the main elements. And now we go into the cascade system. So let's go back to our concept. So what is the concept? The concept is capture the water during the rainy season. It's a simple concept. Did not occur to people in other countries. Not that they were stupid, it just didn't occur. So they figure the water comes here to the first reservoir. And if you go here, so water comes here, and after irrigating this during the rainy season, they could irrigate this paddy field, and the water still goes away. So they said, wait, this water is getting wasted, so let's build another reservoir below. So that's what they did. So that's a cascade system. And there's a good picture by someone named Kawindra Paranage. I obtained from the internet. Credit to him. Kawindra Paranage. And here you have the water coming to the main tank and then goes to this tank. So it's a system, cascade system. You know. So again, going back to our concept, do not let water seep away to this ocean. This was properly said by King Parakram Bahu. Here, King Parakram Bahu said, let me get the quote here, if I can find. Here, King Parakram Bahu said, in the realm that is subjected to me, there are, apart from many strips of country where the harvest flourishes mainly by rainwater, but few fields which are dependent on rivers with permanent flow or on great reservoirs. Also by many mountains, by thick jungle, and by widespread swamps, my kingdom is much straitened. Truly in such a country not even a little water that comes from the rain must flow into the ocean without being made useful to man. So again, that initial concept very well articulated by King Parakram Bahu. And then he goes on to say, when it is the case of a difficult task, all with untiring energy must not regard it as hard without neglecting the command given by me. You must fully carry out the work as ordered. So he says, if I tell you to do something, don't tell me it's difficult. Just do it. So, going back, so the concept is capture the water that comes during the rainy season to be used during the dry season. So that's the concept that they ran with it. So they built these reservoirs, they built the BISOKOTUWA to solve the problems that came along, the PITAWANA and these other elements. And then the water coming out would be captured through a cascade of reservoirs. And then the next step. Next step is, even during the dry season, all these cascade reservoirs went dry. And then they saw these streams, which are ephemeral streams. Ephemeral means during the dry season, these streams would go dry. So during the dry season, they could build anicuts across these ephemeral streams. Ephemeral streams are streams that go dry during the dry season. So it's easy to build these anicuts or weirs. And now they could get water during the rainy season for these reservoirs. So when the dry season comes, there's more water here because they fill them up to the top. So that's the next step. And then the biggest step. This is the biggest step. Now there are rivers called perennial rivers. These are constantly flowing rivers. These are constantly flowing. Perennial rivers are constantly flowing rivers. So if the water is flowing 365 days per year, how are you going to build something here? That was a challenge. And the King Wasaba was the very first person in the whole world to build an anicut in a perennial river. Now there is water throughout the year. In the past, they look at this year during the dry season, no water for paddy field. But there's plenty of water here in Mahaveli Ganga, which they call Mahaganga at that time, Mahanadi. And then the Ambang River, which is Malwatu, is Kadamba Nadi. I'm just going by memory here. So there's water in those rivers. And they just look at them and say, oh my God, this water is just flowing all the way to the ocean. We cannot touch it. It's a problem. You cannot take water from a constantly flowing river. It's a big task. All what you could do is just look at it. Well, what are you going to do with buckets? Fill it with buckets and bring it over for the paddy fields? Not going to work. And building an anekkad across a constantly flowing river is not an easy task. It's not easy today. It's not easy then. Today you have to build, we have concrete, so that makes life easier. And King Vasubha was the first to build a dam across the Perennial Rivers across Ambanganga. Now they have a constant flow of water. During the dry season also they have water. So huge reservoirs can be built because now they have constant flow of water. So this is the introduction. So I'm going to go through this other parts that I'm going to talk about. This part 2 is, so part 1 I would further discuss these reservoirs and these photographs that I got from the internet, and I will go through these photographs in detail. This is a sluice. This cobra sign, meaning that the protection of the sluice, or I believe that's what the scholars say. I believe this means that you touch it, you will be punished. So the sluice cannot, nobody can touch the sluice, do any damage or any modifications. So that is my view, and these are various sluices. In part 1, if you would, I will be discussing these sluices, and in this PITAWANA or a spill. And in part 2, let's go to part 2. So this is all I will be talking in part 1. In part 2 is all about BISOKOTUWA. It's an engineering marvel. So it will be all about BISOKOTUWA in part 2. And so I would talk about different types of BISOKOTUWA. And in part 3, I will talk about Cascade System, utilization of ephemeral and perennial streams, and further we discuss these systems, and that will be part 3, and I'll be talking about the Alhara Canal also, and the network of reservoirs, the Cascade System. I will go in detail. And in part 4, I would go through historical references to irrigation from Mahavamsa and other historical documents. That's very interesting. You should join that. So this is the ancient names for the rivers that we have today. Like historical references, the Mahavamsa references, and then the references from the inscriptions, Gallo inscription, and so there were officers in charge of canals, we could see in the inscription, and the Queen Anula giving a reservoir to monks, and there were water taxes. People were paid for working in the tank in certain inscription. Revenue from fishing, so they were fishing and there were revenues, and that has to go to per certain part to king. And then king also had to buy tanks from others. I will go through this inscription. And one can own portions of a tank revenue. It's like stocks. Like you could own a company stock, a portion of a company. And one part of 10 parts could be given to a certain person. And women also owned tanks. People, not only king, the people were allowed to own tanks. And so these things I will be discussing in that part. And then there are a lot of information. And part 5, and what do we know about mathematics and irrigation engineering of ancient Sri Lanka. So I would go through Mahavamsa and other historical books, the Puja Avalia, and etc., and inscriptional information. So part 5 is that, if you join. Part 6 is hydraulics. We will go through Bernoulli's equation application, mostly for BISOKOTUWA, and discuss modeling using CFD, computational flow dynamics, and scale model by others. And part 7, I would do an artificial intelligence modeling for BISOKOTUWA and water distribution. So these are the 7 parts, and I hope you would join me with all the parts. And thank you very much for listening.